Hi friends, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Isa Saidah binti Muhammadiyah from IC2202B from Group 7. For today, I want to present about eyes and camera's everyday light sensor. What is that? How the eyes work? All the different parts of your eyes work together to help you see. First, light passes through the cornea, the clear front layer of the eye. The cornea is shaped like a dome and bends light to help the eye focus. Some of this light enter the eye through an opening called the pupil. The iris, the color part of the eye, controls how much light the pupils lets in. Next, light passes through the lens, a clear inner part of the eye. The lens work together with the cornea to focus light correctly on the retina. When light hits the retina, a light-sensitive layer of tissue at the back of the eye, special cells called photoreceptor, turn the light into electrical signal. This electrical signal travels from the retina through the optic nerve to the brain. Then, the brain turns the signals into the image you see. Basic of how a digital camera works. Okay, the basic process of how a camera works, regardless of whether it's the best digital camera or any other type of camera like a compact camera, is not all that different. The light from the scene travels through the lens and strings, some sort of light-sensitive surface inside the camera body, but the type of surface that measures the light and the method by which the camera uses that surface to create a photograph separates digital cameras from other types of camera. How do cameras see what we see? Our vision is stereoscopic. Humans have two eyes and each look at something from a slightly different angle. This enables us to judge distance and determine how close objects are to each other. Stereoscopic cameras aside, cameras see through a single lens and record the world into a dimensional image. Next, what are the different types of light sensor? First, photoresistor. Photoresistors are also known as light-dependent resistor. Second, photodiodes. Photodiodes are a type of light sensor that convert light into an electric current. Third, phototransistor. Phototransistors are similar to photodiodes in that they both convert light energy into an electrical current. Where can a light sensor be used? Light sensors have a lot of use. The most common use in our daily life is in cell phones and tablets. Most portable personal electronics now have ambient light sensor used to adjust brightness. How do you take pictures in the dark with your phone? Often, the easiest trick for lighting up a dark scene on your smartphone is merely adjusting the exposure. Most Android smartphones offer this feature directly in the viewfinder. Tapping the screen and dragging the exposure meter is enough to lock the exposure of the shot. It works similarly on the iPhone. How does a camera see light? A camera lens takes all the light rays bouncing around and uses glass to redirect them to a single point, creating a sharp image. When all of those light rays meet back together on a digital camera sensor or a piece of film, they create a sharp image. What is the maximum angle a human can see? The approximate field of view of an individual human eye is 95 away from the nose, 75 degrees downward, 16 degrees toward the nose, and 16 degrees outward, allowing humans to have a slightly more than 118 degree forward-facing horizontal field of view. What is the difference between eye and camera? Okay, eye, left organ for sight. Camera, equipment to capture image. Eye use light cells to detect light, and camera use a diagram to detect light and capture image. That's all from me. Thank you so much for your patience and your listening. Congratulations on listening to the end. Bye bye. See you again.
Assalamualaikum warahmatullahi wabarakatuh. My name is Zulfa Ala binti Adnan. So we will move to the next point, which is telescope as a giant eyes. So I will share with all of you the basic knowledge of the telescope. Okay. Have you ever questioned yourself, which is what can the pull of gravity tells us about dark matter? What shape actually does gravity make the universe? So to answer all these questions, that's why astronomers need a telescope to observe the image of the sky or the galaxy. So basically, telescope are like a giant eyes, which is collecting the light to see the images. So there is two most important properties of a telescope, which is first is light collecting area, which is telescope with a larger collecting area can gather a greater amount of light in a shorter time, while second is angular resolution. Telescopes that are larger are capable of taking images with greater detail. So next point is basic design of the telescope. There are two basic design of telescope, which is a refracting telescope and the second is reflecting telescope. So the refracting telescope, it focus the light with lens, while reflecting telescope, it focus light with mirror. So the refracting telescope is need to be very long with a large and heavy lens, while the reflecting telescope it much greater diameters, and it's the most modern telescope for sure. So the last point is what do astronomers do with the telescope? So basically, it has three main functions of the telescope, which is first is imaging. Imaging the imaging is they taking pictures of the sky. The astronomical detectors generally record only one color of light, as you can see from the image at a time. So several images must be combined to make full color of pictures. So the second one is spectroscopy. The function of spectroscopy is it will breaking the light into spectra. A spectrograph separates the different wavelength of light before they hit the detector. So the last one is time monitoring. The function of time monitoring is it measuring how light output varies of the time.
Did you know what is atmosphere? The atmosphere is a layer of air that envelopes the earth. The atmosphere is composed of various gas elements, 70% nitrogen, 21 oxygen, 0.93 argon, and carbon dioxide. The atmosphere is divided into several layers named as troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Troposphere begin at height 0 until 12 km, and almost all the phenomena head in this level. Stratosphere begin at 12 km until 50 km. In this layer, the air temperature increases with the rise in altitude. The lowest layer is known as the ozone layer. This layer serves to protect the earth from exposure to UV radiation, or known as ultraviolet. Mesosphere begin at height 50 until 80 km. In this layer, there is a decrease in temperature of 0.4% every 100 meter. The air temperature is very cool, reaching negative 100 Celsius. This layer serves a shield of meteor rain heading towards the Earth's surface. And thermosphere begin at height 80 until 700 km. In this layer, the heat can hit until 1100 Celsius until 1650 Celsius. The lowest layer in this section is the Kármán layer. The layer serves as a reflector of radio waves. The last is the exosphere. The air temperature here reaches negative 57 Celsius. The exosphere layer starts at an altitude 700 to 1000 km. This layer serves as an artificial satellite site. The lowest layer of this part is known as exobase. And about the telescope, there are three types of telescopes, named as telescope reflector, telescope dioptric. There are three types of telescopes, namely telescope reflector, telescope refractor, and dioptric telescope. The first is a refractor. The refractor works on the principle of refractions, namely the deflection of light. Light enters through the objective lens, and then the light is refracted to rear lens of the ocular lens. The second reflector telescope. The reflector telescope works using a principle that is almost the same as the reflector. Telescopes that collect light equally, the light waves entering through the optic tube will continue towards the concave mirror. Light enters through the windshield and is reflected to the ocular lens. The third is a catadioptric telescope. Catadioptric is translated from English. Catadioptric optic system is a system in which refraction and reflection are combined in an optical system, usually through a lens and a curved mirror. Catadioptric is combination are used in focusing systems such as headlight, spotlights, early beacon focusing system, optical telescope, microscopic, and telephoto lens.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Firdaus bin Abdul Wahid. My student ID 2020@34512. So today I will continue my subtopic in our topic group 7, topic 4, telescopes as portal of discovery. So my subtopic is telescope and technology. So the first, a telescope is a type of optical device used to observe distant objects by focusing all the electromagnetic radiation, such as light. The term usually refers to optical telescopes, but in addition, there are also telescopes used for most of the electromagnetic radiation spectrum and for other types of signals. The telescopes consist of two lenses, namely the objective lens and the eyepiece lens. The objective lens focus a distant ray of light and the forms a clear, inverted and diminished image at the focal point of the eyepiece, while the eyepiece manifests the image of the objective lens. The development of observational science and technology in the last 5 centuries has led humans to understand celestial objects free from the veil of meteorology. Galileo Galilei (1564–1642) with his refractor telescope was able to make the human eye sharper in observing celestial objects that could not be observed through the naked eye. Since the Galileo telescope could observe more sharply, it could see various changes in the shape of Venus apparition, such as Venus crescent or Venus full moon as Venus position change toward the sun. And the field of astronomy is growing, especially after the success of the invention of the telescope. Among astronomers know, the Italian scientist Galileo Galilei was the first person to create a telescope to look at the sky in 1609. An optical telescope is a telescope that aims to collect light or focus light primarily from the visible light spectrum of the electromagnetic spectrum, although there are some that also aim to collect infrared and ultraviolet rays. Optical telescopes are used to magnify and clarify the shape of objects at long distance. This is to ensure that image can be observed, photographed, studied, and sent to a computer. Telescopes are equipped using one or more curved optical elements, usually made of glass, to collect light and other electromagnetic radiation to a focal point. Optical telescopes are used for astronomy and in many non-astronomical instruments, such as binoculars used for bird watching and binoculars for the purpose of observing the surrounding nature. So there are three main types of optics. The first, refraction telescope that use lens to form an image. Second, reflecting telescope that use an arrangement of mirrors to form an image. And the last, catadioptric telescopes that use mirrors are combined with lenses to form an image. So we go to the technology transfer. Some of the results of astronomical research that can be transferred by its technology. The first, such as development of CCD detectors. Second, image processing techniques, communication using satellites. And fourth, development of robotic. So that's all from me. Thank you.
Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Umi Maisara binti Muhammad Izam and my matrix number is 2020878364. So for this part, I will take over and continue the slide about the topic that you can see on the slide, which is basic of handling telescope. So for this topic, there are 4 steps in the basis of handling a telescope, and this step useful for beginner and experience. Alright, let's go to the first step, basic of handling a telescope. So firstly, you just need to assemble the parts of a telescope. So if this is your first time handling a telescope, so you just put your telescope together when you are indoors and have lots of light. Once you are finished with assembly, stay indoors and take some time to learn a bit more about its features. Okay, right next, the second step is choosing the right type of telescope for the specific usage. Okay, that means choosing the best type of telescope based on surrounding areas and what you want to locate through telescope. So there are three types of telescope basically nowadays. Okay, there are reflector, and catadioptric. Okay, different object and different place need different types of telescope and different power levels. For example, if you want to bird watch, you will be better not choosing the reflector because it wouldn't show you terrestrial objects. Meanwhile, refractor or catadioptric telescope might be the best option if you are in a place where it used frequently and you are planning on using the telescope at night. In addition, for per inch reflector, you will get 50 power, so you should go around 150 power to get better result. Alright, we go through to the third step. Okay, third step is understand the telescope. Okay, for this step, you have to learn three things that is the basic things adjusted in the telescope. So first thing you need to know, understand and learn is about find the scope. Okay, find the scope is typically attached to the side of the telescope. Okay, find the scope also has the special ability of covering more area than a telescope itself. For example, a 50 power telescope covers an area about as small as the fingernail on your little finger, whereas an 8 times find telescope covers an area about the size of a golf ball. Next, the second thing is learn the mount. Basically, there are two types of mounting in a telescope. One is azimuth mounting and another type is equatorial. Azimuth mounting can rotate the telescope in various positions, like up to down and side to side, while equatorial telescope can be moved in up to bottom position. The movement of the telescope is quite different and complex. It has two axes of movement, which is swings across north to south and east to west. Okay, and the lastly is about tripod. Okay, tripod is one of the important things part of telescope because without that tripod, we will face the focusing problem due to loss of stability. Okay, now we have reached the end of the step. Okay, it is exploring the sky. How to use telescope properly, scan the sky smoothly is our main objective. So that's why we need to apply some basic fundamental and some tricks to get the excellent view of the object. Okay, there are three things that you need to do before exploring the sky. So as you can see on the slide, the first thing is figure out what you are looking for. For example, you want to look at moon, birds, stars, and anything else. Okay, second is about find out timing, place, and weather. Okay, find out timing, place, and weather is important things before you start exploring the sky. For example, you can go for watching stars in a cloudy sky. For watching star, the best suggestion will be in a moonlight. Okay, the third thing is avoid the light pollution. Okay, why? Because light pollution is main problem in part of observing through a telescope. Okay, to avoid light pollution, you need to afford as much higher place as you can. That's why the entire telescope observing things happen in the higher place. Okay, last but not least, for reminder, I just want to remind, if this is your first time handling a telescope, you need to practice quite a few times with the telescope. Okay, I think that's all for me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amiruddin bin Azami. My ID number is 2020470224. My topic is about Galileo's telescope changed the world. First of all, I want to talk about Galileo biography. His full name is Galileo Galilei. He was born on February 15 in 1594 in Pisa, Italy. After that, he died in Arcetri, Italy on January 8, 1642. He was the first of 6 children born to Vincenzo Galilei. As well-known musician and music theorist, and Giulia Ammanati. He was a mathematics professor who made pioneering observation of nature with long-lasting implications for the study of physics. He also the first person to construct a telescope and supported the Copernican theory, which support a sun-centered solar system. Next, we go to how Galileo built his telescope. Firstly, in 1906, he heard that in the Netherlands an instrument had been invented that showed distant things as though they were nearby. After he bought the instrument, he figured out the secret of invention and made his own three-powered spyglass from the lens for sale. And Galileo built several telescopes, but today we can see two of them. They are made of wood. One is covered with paper and another one is covered with red and gold leather. Next, we can see on the picture of Galileo's telescope. There are two of them. First telescope is about 136 centimeters long and 6 centimeters wide. Magnifies about 15 times. The field of vision is around 15 seconds of an arc. It is enough to see half the diameter of the moon. The second telescope is 92 centimeters long and 6 centimeters wide. It magnifies about 20 times. Its power separation 10 seconds of an arc. It can see half the diameter of the moon and the satellites of Jupiter. Next, we go to Galileo discovered moon phase. He seen moon phase through telescope and drew about it. After that, he discovered 4 moons revolving around Jupiter. After these discoveries, Galileo quickly produced a little book. The book's name, Sidereus Nuncius, in which he described them. He dedicated the book to Cosimo de' Medici in 1590 to 1621, the Grand Duke of his native Tuscany. Next, in March 1610, he published a small booklet, The Starry Messengers, revealing his discovery that the moon was not flat or smooth, but a sphere with mountains and craters. After that, he found Venus and phases like the moon, proving it rotated around the sun. He also discovered Jupiter had revolving moons, which did not revolve around the Earth. He also supported the Copernican theory. That's all from me. Thank you.